And welcome to Sergio's talk about everybody's favorite kind of software, antivirus software. Have fun.
Okay, I will talk about research that I've been doing about antiviruses. So, well, first, this is a must-have, right? So it's the greetings to my wife and my sons because I took their time for doing this. So I'm Sergio. I work as a security researcher. I'm from Argentina. I came to Germany like 2 years ago, and I'm working in runs. So we will I will present like a few introduction about like antiviruses things, some myths around the antiviruses, the facts, common problems I have found, how to hunt these security bugs. I will do a small demo, and final comments and questions and answers. So basically, how many people here has antiviruses installed in their systems? Raise your hand. Okay, we have quite a few. That's good. So basically, what is an antivirus? Basic antivirus is a software that have to detect a malicious software that could be like transferred by any kind of medium or reading or writing on the disk or whether if it's holding memory. So basically nowadays we can find antiviruses located in many places. So basically they're like almost everywhere, right? So we have on the mail servers, we have in our web browsers, in our web servers, especially when we have to like upload, submit things. They have like locally installed antiviruses that scan for the file system. We have like through the gateways and also in the servers that hold like FTP, like file sharing, and things like that. We have in the file server, we have in the database whenever we upload and download and write things. Every read and write that we have on our hard drives, it used to be like scanned by the antivirus itself. So not just when we send a file, it's just whenever we click on any kind of file, the real time is going to try to detect if we are going to touch or execute some kind of malicious software in our machine that can cause some kind of damage. In instant messaging software, that is a very interesting one because if while somebody sends you something and you receive it and your antivirus scan for it, it can also like be a target here. And in any kind of gateway that we put, like there are many solutions nowadays that enables you to analyze any package that passes through the network. So using those gateways, you have exactly the same thing with the appliances. Those all-in-all boxes, those boxes that do like everything. So this is like something interesting to research on because it's like basically everywhere. And which could be like the approaches that these guys have is like scanning the memory. Not all the antiviruses do this, except when it's like on demand. But on real time, they don't use to like scan the memory all the time, right? It's just whenever we handle some kind of file, some kind of packet. They have to deal with file formats, a lot of file formats. They have to live with packers. They have to live like exploits. I haven't seen that. I just want. So they also have to deal with whenever you receive like an exploit, even in source code. Many times they also detect even the source code. Whenever the source code of an exploit is in a file, they just say, "Oh, here is the exploit, blah blah blah," and they just delete it or whatever policy is. And then we have the different kind of engines, the way the engines work. So we have the heuristics that basically try to analyze and try to understand the files to try to figure out if that is a malicious piece of software or is not. Then we have the ones that, that it's actually the way that all times all the antivirus used to work, that is by patterns. So with patterns, it just have like a signature file, so it try to match. Okay, this signature belongs to this. When it's found, it catch the antivirus. So that is a very weak one. It used to be like the old and most used one. It's the fastest one though. But they have like very, I mean, now they improve it, but in the past it was like as easy to bypass the antivirus as opening the file, add a knob in the file, close it, send it again, no more match, pass it away. And by suspicious behaviors. So if basically these kind of antiviruses that actually try to do like a host IDS, IPS thing, right? So basically if we have like a network like this, and we think about the places where the antivirus is actually located, it could see something like this, right? So except the people that is using the computers and the internet itself. We would have like our whole network like basically not owned, but yes, handled by antivirus solutions. So where can we also find antiviruses now? We can find it obviously in appliances, but basically in 90% or more than 90% of all the computers, servers, laptops that are around, in appliances, PDAs, and even phones. So nowadays, with this Windows C and these other solutions, we have like even viruses, okay, solutions, antiviruses on the phones. So it's when it comes to where these antiviruses are spread, it's like really huge. So there are some myths around this. So this could be like one of the first myths. That is like if you see things. So first of all, the first myth is that the antivirus software is secure, and we will discuss this. The second one is that it makes our network more secure. What it does is it makes our network to the software to prevent those files to pass through. It doesn't mean it's not like a firewall that don't like let somebody pass. It's like a, if you want to call it somehow, it's like a firewall that actually rejects some kind of files. But actually it analyzes them. And this is the most common one, that is that I imagine that more than 90% of the people think that antivirus developers are like computer security experts. And that is not really the case. A developer is a developer, a security expert is a security expert. A developer can have a lot of knowledge, and they could know a lot of things about security. That doesn't mean that they're going to be like security experts. Even though, if they have some technical lead in the development department, the guy cannot like evaluate and basically audit himself all the source code from anybody. So even though if they have one, this common myths around the antivirus development is not like that. And if you talk with most of the companies, the guys are like just developers. Maybe they have some guy that helped them, or they try to develop something that improves their code. They're not like security experts. And then this is, okay, nowadays people start to change about this, but about the detection. Most of the people used to say, oh, I have my antivirus, so I will not get infected. Or when you talk with different companies, oh, but I bought this antivirus, I update every day, I try to do my best. So, and they hopefully don't get infected, they do anyway. And the other one is, my antivirus says, because of the heuristics, that is going to detect even unknown viruses. That is somehow true, but obviously there is always one. So here would be like, we are going to discuss about the security stuff. This is going to be our main topic today. What I said is, the guys are just programmers, coders. About the detection, okay, most of many antiviruses used to don't detect the old viruses. I think this is because of an overhead to make their engines faster, to actually catch better and faster any kind of malware or virus or Troyes or whatever they are analyzing. That are the ones that are most spread on hotspot nowadays. So they try. What I think is that they focus on that instead of focusing on the old stuff. But the fact is, if you send like a very old virus, okay, you are not going to try to use a DOS virus against Windows because probably it's not going to work in many cases. But okay, not all the antiviruses actually implement all type of packers, just the most widely used ones. So it's the only things that they can actually analyze. So bypassing the antivirus is like pretty straightforward. About the numbers of achieving files, most of the vendors used to have around 15, like the most common ones like gzip, zip, rar, like the most common ones. When it comes to like not that uncommon ones, basically the engine is not able to actually analyze what is passing through it. What happens on the other side is that the most popular software, when they receive the files, they're able to open it. So there's kind of discrepancy in there. So like for bypassing techniques, that is like very, very, very powerful if you want to send something. Especially if you want to test your antivirus solution, that is a very good way to go. And then, okay, somebody have to get infected first. So what is the first fact that we have that is like the most important one? We have to have our antivirus in our machines. Otherwise, if we are in a company, we are not just aligned with the policies that we have to be aligned. So we just cannot say, oh, we are not going to use antiviruses because you, like by internal policies and best practices, like you are out, completely out. So you have to use them. So which could be like the common problems that these guys have or had or they keep having is, okay, in my research I found a couple of things that are like really interesting. And this one I'm not going to say the name because they didn't fix it yet. But the thing is they use like protocols to communicate and like doing like updates. If there is somebody from this company, he will know who I'm talking about. So basically they use Blowfish to encrypt the whole traffic. The thing is this key is stored in the binary. So whenever you go to the binary and you check for this key, the only thing that you have to do is use the same key, put any kind of update in the packet that you want to send. You just send it, the guy on the other side receive it, check, oh yes, it's a correct package, unpack it, install it. So basically you can own the whole network doing this, right? And it's there, it's like known something that you actually deploy to the client to receive something with a specified by the administrator. So it's something that is there, it's hard-coded in the binary. And proper password handling, this is a very nice one. Actually, Trend Microsystem, a while ago, used to, so for example, whenever you use like this office scan, you have like an configuration file in the client side. So I didn't try lately, so I assume that they already blow this away. Well, but I'm not sure, so maybe you should check it. The thing is, in the configuration file, they store on the client side both passwords, the client password and the the password for the admin for the administration of the whole antivirus. So and the algorithm was so easy that the only thing that you had to do if you wanted just to reproduce it like manually is it was like a base 64 one, but you could do it like manually. The only thing that you have to do is like type 1 to 0 and A to Z, and if you wanted other characters, and send first only one, or actually you could send the same one up to like 10. So each one was going to be like a different character because it's like position dependent. So you store that in a table, then you go to the next one, do exactly the same thing with all the characters. And when you are in front of the real password, the only thing that you have to say is, okay, what is the character that I have in the first column? Is this one? Okay, it's this character. Which is the second one? It's the second one. So it was as easy as doing that. So it was like really straightforward. It was also even installed in the registry key. So actually, I don't know if they store that nowadays either. It wasn't like the real mean of my research in this case, because I was like more interested in getting in from the out and not having to be in the machine to do that. So then on the client listeners, you have like the common things, but that is very common in all the software, right? So you have a communication channel. The communication channel could have a problem or not. And then you have a lot of problems with null DACLs. I don't know if you guys are familiar with a null DACL is. Basically, when you generate like a handler, to the handler you can apply different kind of permissions. So for example, if you create like a shared section, you can say this shared section can be only readable or delete or whatever by this guy, this guy, this guy, this guy, or this group and this guy. And all the policies that actually you can apply on a Windows system, you can apply to the DACLs. So basically, when the second argument where you're calling the API that is set security DACL, the second argument is actually the one that have this description of the DACL. If the DACL is null, means everybody can do anything with this. So there are many pieces, many antiviruses that actually allow this, and I will do a demo on this one. So with these null DACLs, you can like modify registry keys. You can basically modify depending on the file permissions that you have on the file system when the starter starts the whole stuff, and on the handlers, especially on the handlers. Oh, sorry. Oh. So, for example, if we come like to this is fprod. So fprod has one of these ports that actually is an LPC port. So you can see that everyone can like delete, synchronize, query, state, even anonymous logon. So that is bad, okay? Because you shouldn't be able to modify these things. At least they should be like logged on users. If this LPC is like correctly implemented, if it doesn't have any kind of bug, this shouldn't be the case. So this is like real bad policy, right? Okay, other problems is like whenever you are in front any kind of archiving format like zip, cab, you have different fields. That is like the structure that is the one that actually compound the whole data type, that in this case is the format of, for example, a zip file. So many antiviruses, actually most of them, if not all of them, when they deal like with the integers that are the fields that actually describe the length of the data or the size that they are going to parse, instead of they checking exactly which this section length or size is, they just believe whatever is here. So what is going to happen? If this section says like, if they're using like a double word, that the maximum size is 4 gigs. It's like FF. And you use that number, and this guy is using +1 to actually add a 0 in the end. When they malloc that, it becomes 0, so they're going to like create a buffer of 0 size to allocate something that could be any other site. So whenever this guy tries to write in that buffer, it's going to basically overflow. It's going to write anything that is behind that. This is a very nice one. Actually, this was found by another guy that should be, I don't know if it's here. There is Pierre. It's a guy that used to work with me. So basically, he was playing with gzip, and in the specification of gzip, you can actually concatenate different gzip files. So, for example, you do a gzip of a directory of a file, and you do a gzip of another directory of another file, and then you say cat file1, file2, and just the output of those put in only one file. You just make the two files one. That is actually aligned with the specifications of the gzip. So if on some antiviruses you just concatenate two files, the first one was going to be analyzed, and the second one is not. So that is completely bypassed the parsing and the detection engine. And this is a very common one. This had been changed in the last 3 months, but there are many that still have these kind of problems. That is dealing with the files. What happened with reading files is, okay, antiviruses used to deal with very small files. You cannot like send like 2 gigs files every day to anybody, probably because of the mailbox policy, this will not even pass, right? But when it comes to like locally storage, as they used to use like integers that are signed instead of unsigned, the maximum size positive that you have is the 2 gigs. So if you pass that, then it's smaller. So locally it's very funny because you do a file that is more than 2 gigs. And they used to have a lot of problems. Especially when you're not aligned with the header, right? So for example, what I said before is the thing about if they are aligned or not with the most common software. If a most common software is able to decompress some kind of file, the antivirus should be able to recognize it, because otherwise it's going to be unpacked, it's going to be executed in the system, or it's going to be like anything. If it's an exploit, the machine is going to be exploited anyway. And I met a lot of many, not the guys that used to work in the research labs, but many guys that are like not selling the products or selling, like giving support. They really believe they even really know about security when they really not. Okay, maybe the guys that design the software, probably the guys that design software know, but. So, which could be like the main topic today is like, okay, which is our main entrance from the outside? It's just sending some kind of file. So, basically, I see a lot of different file formats that an antivirus have to deal with. So my question basically is how the antivirus is going to be able to actually handle them all when the guys that are actually do the compressions that they are using inside are not able to, and they have like a lot of problems themselves. And okay, this looked like really, really scary. And when you start testing this, it becomes more scary though. So these are some advisories that I launched. I already reported like more than 80 vulnerabilities in the antiviruses. They already have been fixed, like 30 of them. And it was just what I reported, right? There's a lot of people working on this. So, and I want to just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should have like 40, at most like 50, 60, because I want just you to remember that there are like 60 or something like that file formats that the antivirus have to deal with, because I want you to remember that number, because there is something that comes after this. So what are going to be the dangers here? First of all, IPSs and IDSs from the same manufacturers, they have to reuse their engines. So they're going to be, they have to reuse them because they have to only fix it once, right? It could be like really stupid if you have like one engine from here, one engine there, one engine there, and you have to patch each bug each time. So this is good. What is bad is when you find a bug from one vendor, basically you can exploit all the branches of products that they have that are using the same engine. The impact is obvious. You will have like denial of service. Nobody wants to have like their mail server down. If you have your database, you don't want your database to be down. Then the bypass detection thing, that is going to be, I'm going to be infected with a known virus. That is not good either. Settings modification. This is very funny. For example, I think they changed it lately. But also train microsystems, you only have to go to the registry key, and you only have to, there was a key that is enable the user to disable the antivirus. So the user, any user, could go there, click and say 1, set to 1, close it and say the button, and then you have the shut down the antivirus enabled. So if you are in a company, you have like a company policy, you don't want that to happen, right? Elevation of privilege, this is when they scan locally, or when you are like in your system, in your corporate network, your administrator gives you such a low privilege and you want to elevate them. So basically what you can use remotely, you can use like locally too, in this case. But elevation of privilege is something that is even bigger. It's not just with the archiving file formats. Then obviously we have like remote code execution. And with the remote code execution, we have like a huge problem. So for example, when I start to test some of my files, I just send the mail to a friend of mine, and I don't know if you can read here. Basically, Gmail, the Gmail guys from Google, they didn't want to tell me what antivirus they were using. And I kind of understand that, right? So basically, now this doesn't happen anymore. But it was just, I don't know if you remember, like about 1.5 years, there was like a huge amount of problems with Gmail, that the servers were like not really working, and they have like a lot of problems. It was this shit. So I just sent a proof of concept file to a friend of mine to try him on another antiviruses, because I didn't want to install them all in my machine. And this happened. And then I started to have like problems with my Gmail account. And then I sent the mail to the guys that are actually in charge of the security and said, hey, I want to report I have this problem. And the guys started like, yes, even our backup software is like melting down, and they just fix it. They just realized this was the cause of the problem. It was funny though. So another one of the common problems is that this is not with all the antivirus companies. There are many other many companies that are really, really nice to deal with, and they're really kind. And there are some other ones that are like really, really, really tough. I think everybody saw my mail about Norman, guys. There was another one that I didn't want to mention. But these guys are really, really, really difficult to play with, especially the big ones. Like Symantec is somehow difficult. At least it's difficult if you don't know the right mail, and I didn't. And when the guys from support actually answer your mail, you don't want to be there. Because you try to report like a vulnerability, and they tell you, oh yes, I know that you are having a problem installing your software. could you repeat this step and go to start, blah, blah, blah. And it's like kind of annoying to deal with these guys until you get the right content. Okay, yeah, during the research, actually, yeah, as you can imagine, I had to disable my antivirus. So which are going to be our attack vectors when it comes to what is going to be like useful and juicy when we want to like attack an antivirus software? So we have all the things that I mentioned before. That could be like locally or somehow remote. But from the attacker's point of view, what are the things that you are going to use the most? Oh, okay. We have to like send mails with these files, with our exploits. Actually, if we have like a lot of vulnerabilities for different, this is the bad thing. If we have different vulnerabilities for different antivirus, and we want to exploit them all at once, the only thing that we have to do is just a packet file with all our exploits. And you know that you send one file, and you have like 6 antivirus that you are keeping in mind that you can own. So you send one file. If one of those 6 antivirus is behind that, basically they're going to get owned, right? Then in the website, so if we have a website that enables us to upload things, we can send our exploit there and basically wait for our shell on their side. If we are transferring files through FTP, exactly the same thing, especially if they are passing through the gateways. Instant messaging is another very interesting one. Yeah, in any kind of gateways. Basically, if you're in a network and you just send a packet, and that packet gets analyzed by an RPS and IDS, and you're using one of these vendor vulnerabilities in the antivirus engine, then boom, you get those too. With the shared sources, if you have like different machines doing like file sharing, you have exactly the same thing. USB storage and all the other stuff. So we are going to speed up here. So this could be like the tools that you should use, like for capturing packages and see what actually is going on, how they are going to handling the things. But the most useful ones are going to be our debuggers. You can choose any one of them. You can PyMate is a very nice one. Bitrace is a very, very, very nice one. Okay, and some other tools. I will speed up to do a demo. That is, I think, what everybody wants. And for fuzzing, the best thing that you can have right now, okay, right now, like 1 week ago, it was Peach outside, public. Now the Peach and the one that is called Sally from Pedrama Mini is like really, really, really cool too. Yeah, for doing like with these internals, we could like trace each process when they are like scanning our files, so we can see in which one it crashed when we fuzz them. I will skip this. This is like my framework. It's a private one. It does many things that you can combine with other things. The more important thing is when you see the different colors. So when you see like in this case, it's like the zip file. So if you have like the compression, like lengths and sizes are in yellow, and the red ones are the different structures, and then you have the green ones are like string in sizes. So other things that could be like very interesting when it comes to fuzz. So those are the ones that you have to concentrate on. This should be, oh, it doesn't seem so good. It's like a template, like this describing, okay, I will replace this field with this kind of data type. This data type is going to be fuzz. So when you generate like the files, these could be like the things. You can do it by hand though, but it's going to take a lot of time. If you just use like Peach or this Sally thing, even blindly. So I hope this is going to work. So basically, first we will go to the bad policy thing. So we will go to fprod. So if you see in fprod, we have so we have this name pipe, right? So this name pipe, we are going to fuzz it. And we will see what is going to happen when we fuzz it. If it works, right? Oh, it seems it's not going to work today.
Sergio,
Yes.
could you explain what we see? What do these?
Yes. Basically, what it is doing is. Oh, okay. I will try to switch because the machine is like kind of unstable. Basically, this is a name pipe, and I'm just fuzzing it here, and it's just fuzzing this name pipe. So basically, this name pipe, actually, this name pipe is unprotected. So the name pipes, basically, you can even use being any kind of user locally in your machine. You can access it and send data and communicate to it. So by fuzzing, actually, I will stop this. Probably it's because of the buffers that is not. Oh, it's running low battery. That is not good. This is connected, but it seems not to be working. Yeah, it's kind of going to die. Okay, the thing is, please. Is there another place where I can connect? Because it's just going to die. Yeah, but I use it all the time, and it's, yeah. Oh, hold on. It's getting there? Oh. Yeah, that's working. It was hard. Okay. So what it is doing is it's just fuzzing the section. As I said, whenever you try to do a demo, it doesn't work. So we go to the next one. Anyway, this was a local one, so. So we will use like a couple of antiviruses. I would like to install more, but the problem is that the big companies, whenever you want to install more than one piece of antivirus, they just don't let you. So yeah, they didn't allow me to put more antiviruses. So I will just take a couple of those. No, I will show it like pretty fast. Yes. Okay, yes. Okay. I will close this. So okay, so we are going to go after a bus first. So basically this script that I have here, what it does is it basically is a debugger. So it will look for a process, and when the process appears, it is going to attach to it and start debugging it. So we are going to launch a bust. He attached the process. So here are some exceptions. There actually you have like, yeah, they are like real bugs, like real exceptions. The guy should be like scanning them, and you have basically from where it was called each one of them. So basically these are real bugs. If I wouldn't do it this way, I will show other ones. So for example, if you use like this other antivirus that is here. So there you have like one of the bugs for Avast. Actually, there are two bugs there. So if we go after this one, we're going to do a select. We don't want to scan everything, just the ones that we want to see. And we scan this one. If we attach with this, whenever it starts, it's actually going to catch it to see where actually the bug is. So this is useful when you have to code the exploit. So you didn't see any window, but if I just run it without with the debugger, this is what is going to happen, right? So yeah, so here you have like another bug. So basically, with the debugger thing is, the cool thing is actually you can track whatever was in memory. So the content of this file when it was being actually scanned, we can see first that I was looking for the word prueba because prueba is one of the words that I put inside my file. And then you have all the information basically to start starting developing your exploit or having a clue where the bug is, in what place, where the exception was, and actually in what sequence of tasks that the process was doing at the moment. So I communicate with these guys never answer. So basically now this get recorded. So it's like an all-day for free for everybody, right? It took me like more than 6 months hitting every day these guys. There's no way, no answer. They never answer. So we will go after another one. So this time it's going to be Antivirus. This is the name of the process that Antivirus actually loads up. So we're just going to use the Antivirus here. And the device is going to be like looking for it. As you can see, it found like 3 exceptions that are handled one after the other. If you don't catch the first one, you have other 2 chances. And if they are handled, like you just make a huge, not that huge because this file is like really small. A packet of like a lot of sub files. You just send them, and you have like the try the brute forcing thing until you hit the right address and you actually execute your shell code. Actually, I've been told that I cannot because of this new law here, I cannot show really exploit getting shells just to don't get into trouble. But okay, this didn't crash, but the exceptions are here, and actually you can see the whole trace. I don't know if this told somebody to somebody. So here you have another bug there. I will try again with this section to see if it actually dies or not, because I want this to die. Let's see if I'm a little bit more lucky now. So this should be the process. We will try to attack this section again. Please. So this is what is trying to attack this. Oh, this guy doesn't want to die. Okay, it seems this is not going to work today. No, definitely this guy doesn't want to work. Doesn't want to die. Okay, so so there were 4 demos. 1 didn't work. So here, so the machine is like really, really unstable now. So the thing is, with this kind of things like playing with the Packers, not just with the Packers, because it's the file compression things, the Packers. Basically, what happens is that what I've seen is that most of the antiviruses, the large companies now have changed though. They didn't have, actually I don't know how many have changed. At least that's what they told me. But the bugs still are there. So they don't have like a security development process. So if you don't have like a security development process, that is why you have a lot of bugs, right? Somehow they need to follow the step from Microsoft. Microsoft is like trying harder every day. Even though there's a lot of people that just don't like Microsoft. The truth is they are doing their best to do it. So if we think about this kind of bugs, like different Packers, different antiviruses, different bugs, we can put them all together and just do like a real bad thing. So if we think about this bad thing, like it'd be like a worm, and this worm actually installs some kind of rootkit in the BIOS, like the Sean Hisman talks. If anybody is familiar with this kind of rootkits, and if not, I highly recommend to read all the Sean Hisman papers about rootkits. That is on BIOS, on PCI, and in the last Black Hat and DEF CON, he presented against the firmware. So if you think about this whole thing, that is really, 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 really bad, because basically these rootkits survive even if you reinstall your system. So they just are in your machine. Turning on the antivirus is good. Okay. For me, seriously, it's not secure, but you have to do it. So basically about this parsing thing, because the main thing is the parsers. It's just the top of the iceberg. If you start thinking about the IPSs and IDSs, the amount of protocols they have to deal with, if you just have a look in Wireshark, you will see the amount of dissectors that they have. Like, there is like a lot of them. Well, IDSs and IPSs have actually to analyze them to realize if whatever is inside is fine or not. We were talking about like 60, 70 compression algorithms in the antiviruses. Just think about that. At least they have 100 each IPS, right? So there is a huge problem there. And I just started to play with, and it's bad. And I don't want to go against the firewalls, but most of the firewalls now do like decisions at different packet level, and they have to do some parsing too. I wouldn't bet on them either. I didn't research on them though. So the paradox here is like pretty interesting, because it's like the more infrastructure that you put in your network, like I put my whole antivirus, I try to protect my company the best that I can, but at the same time, they have to deal with so many things that if you think it twice, there is a very big problem there, because basically the more you defend yourself is the more that you become vulnerable to these kind of attacks. So what could be like the recommendations? They makes, I mean, for a lot of people, most of people, a lot of sense. It's like, just block all the files that you don't want that pass through your network. Just block them. Don't let anything to actually parse them. If you see some kind of extension, just blow it away. If obviously you have policies that you can apply at domain level. So if the antivirus make mistakes on the registry permission, if it does mistakes at file system permissions, just do your policies on the right way. Just check any kind of software that you install in your machine, in your corporate network, and fix them. You can do it by domain policies. And this is something that I always recommend to everybody. Anytime that any vendor from any kind of piece of software comes to you, their software is the best. The software is the more elegant. The software is the more useful. The more is the most effective, and blah 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 blah. Just hear about the features. Keep in mind the features that they have, and they just go and test them. Because probably there are many things that are like not really true. There are antiviruses that tell you, we can scan up to like 20 levels or something like that, like something brainless. Like if it's packet, they go deep. The thing, the reality says, if you do that, your antivirus is going to be taking ages for scanning each file. And if you have a mail server, those files are basically not going to pass through. So packet, they're going to be cached on the desktop though, because when the files is uncompressed, this is going to be written on the disk, and the antivirus is going to actually act there. So basically, if an attacker wouldn't want to like deal with the frontier, like the first level of the defenses of a company, it just do like a pack. It will bypass the whole detection first, and will attack the internal machines. So from that point on, they're just inside the company, right? So I'm preparing a paper. I will post it very soon in Emran's website. I will send a mail to the mailing list though, but with a very detailed and fields and the tools that you have to use actually to test it step by step, so that you guys can go ahead, read the paper, start testing your software, doing your own templates, your own, but in a way that you can actually, it's like a workshop. So you will be able to like reproduce these kind of things on your side. Because of the time, this is impossible here. Any kind of question?
Any questions?
There are going to be in these slides I will give to him, so they're going to be available to download. So you have all the references on all software that you can play with this.
You said you found, you posted about 80 bucks in rather small amount of time. So I wonder how you find them. So do you just sit down and say, I want to find something?
I took two approaches. One of the approaches that I had was like literally I built up from scratch a framework for fuzzing that basically automate the whole analysis on the antivirus. So it create the file, sent to the antivirus, try to parse and realize if it crashes internally or not, if it throws some kind of exception, because it's like a write access violation. That was one of the approaches. The second approach was just tracing with PyMail at first. When each packet was acting, to actually see if I was calling the right opcode or the right method for the compression thing. Because in the so when you see the tree that the walkthrough, the data flow goes, you see that there are some branches that are not taken. So for actually test those, what I did was like tracing them, looking for common commands that you know there could be vulnerable. So I was looking, especially in the comparison, the tests, to see if there was some opcode, some function that I was not using that could actually make this guy take the other branch on the tree. To go deeper and try to actually spot those bugs too. Actually, once you see it takes one branch, you see what you have to change in your file to actually take the other one and trigger the bug.
But that does sound like you need to have the code, right?
What?
It does sound like you need to have the original source code.
No, you have the assembly stuff. You have to like read the assembly thing.
Okay, thank you.
For the storage sections, there is something that is very, very, very simple. You only have to go whenever it's called, for example, the set security DACLs. You have to look for that for example, in IDA Pro. Actually, there is one IDA Pro, very old version, that is like for free. So you should search for that one. It's like for something, I don't know exactly the number. It's not as good, obviously, as the one that we have nowadays. But for some functions, it's pretty good. So if you go to the binary and look for that set security DACLs in the binaries, go to that place and see the pushes that are before. So the pushes are actually the arguments. And the second argument, that is like if you count from down, so you have where the function is called. The first that you have above, no, the second one, that is the one that is DACLs. If the guy is doing a push 0 or move register push 0, that is 0, then you have like no protection in that one. So you can look for those. It's easy that way. So, any other question? Okay, that's it.